Okay, so I think I'm at a position now where this diameter here, this shiny bit, actually fits inside the boiler barrel. So here we are then. We were talking previously about this copper disc expanding if it got hot whilst in the machine. So I've let this cool down to cold now, and when I pop that in there, it does actually fit in. And I can also take it out again. So this fit that I've got here, I think, is fairly good at the moment. So what I'll do, I'll continue to machine this disc down to that diameter that I've currently got, and machine all this off here, and then I'll take this back down to my mentor at the club and we'll see how we're fixed then. Come and have a closer look at that fit on there. So if I tip that over a little bit, we can see that that is just nicely fitting inside this barrel now. We can turn it, and that machined section is just nicely dropping in, and then it's been held from falling further down into the barrel by this oversized outer diameter here. So I guess I've taken about 10,000ths of an inch off of this face here to create this smaller diameter there. So I'll take this back to the lathe now and machine this across, and we'll come back then and see where we're at. So I've got the workpiece back in the chuck now, and I've lined it up to hopefully get the concentricity of this spinning disc as best as I can in a 3-jaw chuck. And with this mirror I can look down the back of the machine and locate what the measurement is on this dial test indicator at the back here, and I've taken about 10,000ths of an inch off the face of this. So this is currently trying to take a 10th cut now when I draw this back, so hopefully this won't slip on this disc and the belts won't slip on the lathe, but quite probably all of that will actually happen. So I'll just have to go very steadily in, out, in, out, in, out, until such times as I've gone right the way across here, and then we'll try this back into the boiler barrel. So safety spin to make sure that's somewhere near and we're safe. We know all of this is tight, of course. Approaching slowly. Backing out, coming in again. 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 And of course, whilst I'm doing that, this will be warming up, so I need to compensate for that and allow this to cool at times. But I'll continue just doing that off camera, and then we'll come back to it and we'll see if it fits in the boiler barrel. So it's a little while later now, and all that I said might happen has actually been happening. So whilst I've been trying to take a cut across the face of here with this button tool, the lathe belts have been slipping, so the chuck hasn't been turning while the motor's been running, and in addition to that, this disc has actually been turning on this wooden former, which will obviously lose some kind of concentricity about the job when it was made, and also as this heats up, it expands and loses its grip on this wooden former. So what I've decided to do, I'm going to use the DTI that's down here and bring the tool away from the job effectively, and then I'm going to come back in and just take light facing cuts across here, because a 10th thou cut coming this way seems to be too much. It's just locking things up. The copper is gripping in the tool and such, and it's just not working out for me. So what I'm going to do, I'm going to bring the tool away, come back in nice and steady, and just take thousandths of an inch cuts across here until such times as the DTI tells me that I'm down to the original diameter that I've okayed and machined this to. We can see from the numbers here, the number 3 no longer corresponds on the back of here with the number 3. That's because this disc has slipped on this former, which in doing that will obviously make itself more and more slacker as we go on. So I've got to be very careful about how slack I let this become. Obviously the heat will have some effect, it will expand and it will lose its grip on here. So a thousandth of an inch cut across here down to that diameter there sounds to be the way forward. I know these videos are a little bit laboured, but the fact of the matter is I'm a novice and I'm trying to explain what I'm finding for other novices who might also be trying to do the same thing and consider building a boiler. So I'll get this chucked up again now, and I'm going to use the reference here with regard to the number of the jaw. So I'm going to use the original reference because that's what this spigot was set up on, these numbers here, and this having slipped will just be something that's happened. So I've got this Smokebox Tubeplate now resighted in this chuck. I've got this rod pushed slightly up against it, giving a bit of pressure to stop this wandering off if it does expand and become somewhat loose on this disc. And what I've done, these number marks which I've got on the periphery of this diameter, I've also put those numbers on the front face now of this work, because these are going to be machined off. So I'm going to draw this tool back and then just take thousandths of an inch cuts across there. Hopefully the tool won't dig in too much, causing the belts to slip, causing this disc to slip on this former. So that's the next step. So we're now clear of the copper, and I'll just start taking light cuts across now until this DTI goes back to the 9 or 10 thou that I could see in this mirror a few moments ago. Safety spin, just make sure everything's clear. Take up the backlash. So we're back to taking intermittent cuts again, and I'm just very steadily moving the tool in on each pass. When I go one way and come back the other way, I haven't changed the form of this tool moving in at all. That's just the lathe doing that itself. Almost like taking a spring cut, or perhaps there's some amount of movement in this cross slide in that fashion as it's pulled one way and then sent back the other. If these gib strips are not perhaps set up correctly, that would emphasize that. Already I can feel this plate starting to warm up, and the numbers are perhaps starting to disappear now, which is why I put the numbers on this front face. So as we saw then, the lathe was still turning, but this disc was actually spinning on this former, and that friction contract between the two is the only thing that's driving this thing. As this gets warmer, it will expand, lose its grip on that wood former, and as it does that, it will lose its concentricity within the lathe. We can see this starting to wobble a bit more now, so I need to check that out and see what's going on there. I don't know whether you can see it, but as I'm tapping that, it is moving back down the disc, and of course as this disc rotates on that disc, it will wear it away, losing more and more grip all the time. So I need to be very careful of that. What I could do in this little piece here, I could drill and pin through this copper into this wood, and that would give it some kind of a key to help stop it spinning. But we'll see how we go. Increase the pressure on the dowel ever so slightly, so the dowel is now having more effect on keeping that on rather than allowing it to drift off. So safety check, and we'll see how we go. back the tool out slightly. Up to press, I've been coming in from the back side, coming this way, because I wanted to use this sacrificial area here as a sampling area for getting the fit correct for the boiler barrel. But if I'm experiencing difficulty with this drifting off now, and perhaps as well, now I've got that measurement there and I know what that measurement is on this dial, perhaps I'm better now coming with the tool this way into the work, which will then be pushing this onto this former disc rather than trying to pull it off to some extent. So I'll try that. I'll just turn that by hand till I get to a point of contact. We're now at a point of contact there. So we can just see it catching up on it there. So I'll bring the tool away and then I'll start machining from this side to there now, which will hopefully, if anything, force the disc back against there. What I could do otherwise is locate and mark on the front face of here where one of the boiler tubes will go and drill and fix into the front face of this through here into there and fix it with a screw. That would also stop this disc spinning. And if I've located where a tube would go, then that is going to be a piece of scrap copper anyway, so it wouldn't matter about drilling it and fixing it. Tool out a little bit again, just to reduce the friction and drag. So I brought the tool away from the work now. We can hear the intermittent cut. Going to go back across at that same setting, i.e. taking a spring cut almost, and advance the tool by about half a thou. was becoming aired, and as we can see, it is taking a intermittent cut here and there. But we've quite a lot to go, so I'll continue in this format now. Coming from when I'm this side of it, I'll increase the tool depth by about half a thou, and then I'll take a facing cut, and then I'll come back, a cut again, come back, and then I'll increase it half a thou again, or a thou, until we're down to this diameter here, hopefully. And to make sure I get to that diameter, I'll be checking on this dial test indicator down there with the mirror. And currently I have about 18 thou to take off. So we'll catch up with you when hopefully this is all nice and shiny and down to this diameter here. If I have any traumas along the way, I'll keep you informed. So it's some considerable time later now, and what I've been doing, I've been moving this tool forward about half a thou into the job, and then I've moved the tool this way across the face of the flange, then back that way taking a spring cut, then coming back this way again taking a spring cut, and back that way taking a further spring cut, then back this way again taking a spring cut, then back that way. So it's gone across once, twice, 3, 4, 5, 6 times, and whilst I've been going in only half a thou, it's still been enough for the tool to dig into this surface and cause this disc to stop spinning while the lathe and this wooden former disc are still rotating. So that being said then, with this rotating inside of this, we've obviously lost some kind of concentricity along the way. And although I've got the DTI down the back here, and I've been checking it with the mirror, what I've been doing, I've been taking this out of the lathe and trying it in the boiler, and bringing it back and machining some more, and then back to the boiler and trying it in the boiler again. And the eventuality is that this now fits in the boiler, and I've had a word with my good friend down at the railway, and he says that's fine as it fits in now. It's perfect, that's brilliant. But if I were to have been going with the DTI, looking at my DTI now with my little mirror that you can't see, I'm still about 7/1000ths of an inch needing to go into this surface. So that would be 7 thou on this side, and as it's taken it on this side and this spins round, it would obviously take it on the far side. So I would be 14 thou undersized if I'd just gone on the DTI. So my suggestion would be always to just keep removing this and trying it in the boiler. That's what I did, and that's what I found that works for me. But even half a thou causes this to stop and spin on this drive mechanism. So when I remove this from here, I am expecting that inside here this disc will be some scoring where this has been obviously on that metal former that's on the front side of this bit of wood. But in any event, let's go across to the boiler and have a look at the fit that we've achieved and the fit that in theory we're thinking that we need. So here's the upturned boiler barrel then, and here's the finished machined flange that we've got. Now I could take this much off if I wanted to, because this piece here is all that we need to coincide with the dimensions on the plan. But up to that little mark there, I could remove all of that, but leaving it on gives better grip for the silver solder, although it would actually mean that there's less water capacity inside the boiler. But nevertheless, this is the fit that we've come up with. So there it is. And it just goes up and down. And the boiler barrel must be fairly round too, because this does actually rotate as it's going up and down. But apparently that's the kind of required fit that we're looking for this boiler barrel flange. And I've started at this end of the boiler because this is one of the more critical joints on the boiler, in that we're trying to turn a disc to a finished hole. So I'm quite pleased with that, and that's the sort of fit that we're looking for apparently for the silver solder to nicely go down the side. So there we are. We can progress a little bit further with this Smokebox Tubeplate now in another video, but certainly it's down to size.